Ladies and gentlemen, hello and welcome, coming to you once again, not quite live from One Take Studios, where today we've got a topic of inverse trig functions, and by itself it's not a super crazy topic, but it can take you in some crazy places. So make sure you got pencil and paper handy here. Alright, we're going to start with this idea that inverses undo each other. So positive, negative will undo each other. Multiplication, division will undo each other. Logarithm undoes exponential stuff. You remember that, right? So what will undo a trig function? Interesting. So let's say I've got this equation right here because, believe it or not, that is an equation. This says that the cosine of some angle is radical 3 over 2. Theta is a variable and it represents an angle. In other words, if I'm going to solve this equation, I need to get theta by itself. I need to undo cosine. How does that work? Well, cosine is not addition, subtraction, multiplication, division, so I can't subtract the cosine to both sides, I can't divide both sides by cosine, none of that makes sense. I need to undo cosine. What will undo cosine? I'm so glad you asked. Ladies and gentlemen, cosine's inverse will undo cosine. That little cosine with the -1 thing, that is the inverse, that is us undoing cosine. So I'm going to undo cosine on this side, and I'm going to undo cosine on this side. Again, doing the same thing to both sides. Here, these guys go away, that's just theta. And whatever value this is, that's going to be my answer. That's going to be my angle measure. I want to show you a couple things in the calculator briefly here. So, pulling screens over to here. Alright, so I have this set up right now because I wanted to take a look. Make sure that you check out your settings. If you're using trig buttons, you want to make sure that you know which angles or degrees that you happen to be in. So right now we're set up in degrees. So let's call it degrees. Let's call that good and say that's okay. There we go. Okay. There we go. Now I go to my current document that I've got open here. There we go. And I'm wondering, what is the inverse cosine of radical 3 over 2? Well, if I go to my trig menu, because here's where mine are located, oh, look, all those little -1 things are there. So if I just slide over this direction, there we go, there we go. There's the inverse cosine of, and now I can just tell it radical 3 over 2. So we are talking the square root of 3. And then make sure I get out from under the radical, divided by 2, which gives me, 30. What were we in? Degrees. That's right. So this is 30 degrees. Because my calculator is in degrees, my answer is in degrees. What if my calculator was not in degrees? What if I wanted an answer in radians? That's easily enough accomplished here. We'll go back to our home screen and just check those settings again. And this time say, hey, document settings, let's change it. Let's make it not degrees anymore. And let's change this to radians instead. So what happens if we call this radians instead? All right, so now let's go back to our screen from before, back to the current document I've got here. I could do this the hard way or the easy way. I'm just going to go back up twice and hit enter. And because I've changed my settings, I'm just going to hit enter one more time. Oh look, same calculation but completely different answer. Why? Because this time we are in radians. And this is approximately 0.52 radians. Alright, now so keep that in mind. Pay attention, degrees versus radians, because it's going to change the output of your calculations significantly if you're not paying attention. So if I go back to this again, I wrote both of these down, but I want you to think for a second. Unit circle. 30 degrees. What is 30 degrees? That is a 1/6 of a pi. If I had the option between radians putting down 0.52 and putting down pi over 6, I'm going to choose pi over 6 every time, because while this is approximately correct, pi over 6 is accurate. And 30 degrees is accurate. And 0.52 is close to accurate, but not quite it. So the calculator will not answer you in pi's, but if you think unit circle 30 degrees is pi over 6, you could have pulled the answer from that as well. Alright, so a couple things that we should think about. We are going to come back to that problem here in a moment, but if the calculator is in degrees, your answer is going to be in degrees. If the calculator is in radians, your answer is going to be in radians. Pay attention to the details, otherwise you just might end up confused and not realize it. Also, use the unit circle when you can, alright? If I don't need to look something up in my calculator, I'm not going to, because I can get exact values off my unit circle. Radical 3 over 2 is a number that if you've looked at a unit circle, you should recognize that as being a common number that we see. And so I would be looking for, hey, where is radical 3 over 2 my cosine value? And then, what angles make that happen? So, this is something that, oh my gosh, alright. So use the unit circle when possible, absolutely. Please make sure that you make a note of that. But this guy right here, I find that if I do not write this down, students never have a clue, and that quite frankly terrifies me. All right, so when do I use the inverse? When do I use this inverse thing? When you know the trig value and you're looking for the angle. That's what it boils down to. I know a trig value, I do not know the angle, this is when I'm going to use my inverse trig functions. Please write that down. All right, you use the inverse when you know the trig value and you're looking for the angle. All right, so now that is the overall concept of things. Let's see if we can make it more challenging, shall we? Of course, why not? All right, so you really need to watch the directions, whether the teacher's giving you directions, the book is giving you directions, but some questions that you need to have answered. Are they asking for the answer in degrees or radians? Because that might change your output. Are they asking for all values, all solutions, or are they just asking for solutions within a certain interval? And to make sure we have all the bases covered, I'm going to go through examples of all of those things for you, all right? So look at this. That's tons of page space for us to work with here. All right, so this is the exact same equation we had over here, but let's see if we can make it more interesting, because quite frankly, 30 degrees is a very small answer compared to what's possible and what's available. All right, if I think about my unit circle for a second, sketching, 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 where is going to be radical 3 over 2? Well, let's see, cosine is related to x. X is positive over here and here. So ladies and gentlemen, we are talking everything that is in the first or fourth quadrants with a 30-degree reference angle. So 30 degrees, we already said, was going to be an answer, but quite frankly, so is 330 degrees. All right, x is positive in the fourth quadrant, cosine is positive in the fourth quadrant. Both of these have a positive cosine value of radical 3 over 2. So to say the answer is 30 degrees, quite frankly, is a really incomplete answer. So let's say that my directions say that I'm looking for all values, all right, all values. Well, I want to know every single time I end up with the cosine of radical 3 over 2, which means I want to know every single time my angle lands or is coterminal with one of those two spots. So if we are saying degrees, we could word it this way, and we would say, all right, it happens at 30 degrees, but it happens every single time I hit 30 degrees. If I'm looking for all answers, that means for all of eternity. How many times can you swing the terminal slide around and make laps and laps and laps and laps? Oh, that's right, forever. How do I get back to this spot right here, 30 degrees? I go a full 360 and stop. That's going to have a cosine value of radical 3 over 2. And then I go another full 360 and stop. That's going to have radical 3 over 2. What if I go backwards? Oh, that's right. That's going to have a cosine value of radical 3 over 2. So every single time I do an extra lap around, I get a response. Why did I put 360n? Because 360 is a full lap, and n is going to be an integer. N is the number of laps that you are doing. So n can be positive 15, n can be negative 20. N can be anything that's a positive or negative integer, which gets us all of our positive answers and all of our negative answers. So this is 30 degrees, and every single time we hit that mark for all of eternity. But that doesn't get us this spot at all whatsoever. So what if I want this 330 spot? I'm going to have to list it. 330 degrees. But again, I'm going to have a cosine value of radical 3 over 2 every single time I hit this location. So not just 330, but go around another lap and go around another lap. Angles of rotation, people, go around for forever and ever. So again, plus 360, and this is just going to keep going. So if I want all answers in degrees for this equation, this is it right here. This represents every single possible answer for all of eternity for degrees for this right here. What if I'm sticking with all answers, but it's in radians instead? It's not that much of a change, really. We said that 30 degrees, that's the same thing as pi over 6. So we would also say pi over 6, pi over 6. So this is also pi over 6 there. But then again, every single time I do a lap and I hit pi over 6, I want to make sure that every time I hit that spot, I'm making note of it. Well, 360 is a full circle in degrees, taking me around to my next answer in degrees. What's a full circle in radians? 2 pi. So 2 pi n. Again, saying 2 pi is a full circle and n is an integer, positive or negative, that takes me all answers every single time I go a full circle around and hit that spot. Boom, there's an answer. What about this guy right here? What is that? Well, if that's 1/6, that's 6/6, that's 12/6. This is going to be 11 pi over 6. 11 pi over 6. There we go. So again, I want to make sure that I make note of that location as well because it also has a positive cosine value. So 11 pi over 6, and again plus 2 pi n because I want to keep going in circles for all of eternity. My brain kind of puts this together as sometimes they ask for the general solution, and a general might make me do laps, so that's how I piece that together. These are all of my laps, degrees, radians, keep going in circles. That gives me every single answer you could ever possibly want. What if, however, what if I don't want all? If I don't want all, then there's usually some sort of interval. And let's say that my interval is going to be, and this is kind of typical actually, let's say that I want to go from 0, yeah, there we go, theta, and let's do this two ways, shall we? Let's do this versus this. So this is saying I want all the answers from 0 to 360. This is saying I want all the answers from 0 to 2 pi. I wonder, which of these is going to be in degrees and which one is in radians? Alright, so if we're on an interval, I want all answers within that single circle. In other words, not like all, I'm not going to go in circles for forever. I just want one circle's worth of answers from 0 to 360. So what's that going to give me? Well, for here, theta is going to equal, well, that's going to be 30 degrees and 330 degrees. So 30 degrees and 330 degrees. And that's my answer, and I am done. Because I have fit my answers within this interval, I'm not going to keep doing laps, so I don't need any additional answers. That's it, I'm done right there. Again, then, as opposed to for theta for this one, because we can see the intervals in radians, we're going to respond in radians. And again, that's going to be pi over 6, and that's going to be 11 pi over 6. Those are all the answers within one full circle, so those are all the answers that I'm required to give because of the interval. So, are they giving you an interval? Are they asking for all solutions? Are you in degrees? Are you in radians? Your answer can be very different depending on the direction, so make sure that you're paying attention for that. Small things to be careful of. What about, what if I call this negative 30 degrees or negative pi over 6? I can't use that as an answer for my interval. Because this says specifically 0 to 360 or 0 to 2 pi, and there's no negative part of this interval whatsoever, I don't want to use a negative to answer. So I'm usually looking for the positive value to answer and solve my equations. Alright, how you doing? We're getting there, I promise you. The last thing's the worst thing, so of course it'll be fine. Alright, so we're going to hold off to that for now. Okay, here we go. Ladies and gentlemen, actually, I don't need that. There we go. Okay. What have we learned? What do we know? We have the sine of theta is 0.4. So if we think about this, again, theta is a variable. We are solving for theta. We have the trig value, so we're going to use the inverse because we know what the trig value is. It's 0.4. And we are looking for the angle measure. We do not know theta. So this is right here, heads up, this is how we know what we are doing. Other things that we should be aware of. 0.4 is not a value that I usually see on the unit circle. So right now, to pick this up on the unit circle, that's not going to really be an option. Decimals, that's kind of going to be where it's at. Alright? That's the best I can do. That's okay. So if you cannot use the unit circle, you can't. That's alright, but just keep your eyes open and keep that in mind. Should I be answering in degrees or radians? Oh, well, since I have an interval and the interval is in degrees, I need my answer to be between 90 degrees and 270 degrees. Okie dokie. Alright, well, let's think about this. How could this possibly work? Again, if we're going to find theta, we need to undo sine. So, to get theta by itself, we are going to need a value for the inverse sine of 0.4. Inverse sine of 0.4. Alright, so what is that value? I'm cheating because I did it in advance. I'm going to tell you right now, if you type this in the calculator, it will tell you that theta is 23.5782. 23.5782. How many of you guys are like excited? Yay, we're done! I have an answer. I know what theta is, and it's in degrees. Woohoo! Yeah. What does that say again? between 90 and 270. So little mini sketch. 90 is up top, 270 is down bottom. I'm looking for an answer that is someplace in one of those two quadrants. I need an answer that is either in the second or third quadrant. And this answer at 23.5 degrees is in the first quadrant. So even though this is a delightful answer to this problem, it's not the one we're being asked to find. The calculator, are you listening? I'm telling you something. The calculator will always give you the answer closest to 0. Always. Even though there can be, as we've seen, multiple correct answers, all right? The calculator will always give you the answer closest to 0. That might be positive, that might be negative. But how do we make this happen? How do we make this work? All right, well, let's think. Sine and the trig value is positive. Sine is linked to y values. So if you think about x-axis, y-axis, where is the y-axis? Where are the y values positive in a graph? First and second quadrants. Okay, great. Our current answer is right about here. Okay, so that right there, that is our 23.5782 angle. But I need an answer where sine is positive or y is positive, second quadrant, that has the same trig values as my first quadrant angle. What does this mean? Ladies and gentlemen, that's where my answer is. My answer is wherever I can use the 23.57 as a reference angle. So many people try to take mental shortcuts on this. I am begging you, please try to understand what's happening. This says I need to be in the second or third quadrant. This says that sine is positive. Sine is not positive in the third quadrant. Sine is positive in the second quadrant. So even though my angle is 23.57, I'm going to flip that over here and recreate that in the second quadrant. Where is this angle then? You know what? Humor me. I'm going to draw this a little bit bigger. If this is 23 point, I'm going to call it 23.6, okay? I'm looking for something that is a reference angle over here of 23.6. That angle would start my initial side, positive x-axis, and come around to here. The answer that I'm looking for, this is my theta. All right, theta starts here, ends here. But it has to have a reference angle of 23.6. That means my answer is 23.6 degrees away from the x-axis. What number is 23.6 degrees away from the x-axis? Well, let's see. All the way to the x-axis is 180. We want to back up by 23.6 degrees. Ladies and gents, the correct answer for this, theta, is 156.4. 156.4 degrees. This answer, if you don't believe me, put this into the calculator. All right? If you don't believe me, do the sine of 156.4, because I guarantee you the sine of 156.4 is going to be 0.4. Now, I did round this, so maybe it'll be a smidge off, but that's basically it, folks. This number is between 90 and 270. It's in degrees. That's it. This requires that you really understand what's happening, though. All right? Notice sine is positive. Notice which quadrants you need to be in. Work from there. If you can do this, you can do all of it. All right, this is like worst case scenario right here. So if things don't make sense, keep asking questions. Promise me. All right, keep asking questions until you've got it. I promise you it's possible to understand this. All right, good luck. Have fun.